Okay, so this is Algebra 1, Lesson 85, Pythagorean Theorem. Something that shouldn't be new to you. Got a right triangle, sides A, B, and C. Remember, C is your hypotenuse. It's always across from the right angle, and it's always your longest side. And then the formula for Pythagorean Theorem is a squared plus b squared equals c squared. Again, should sound familiar. So an example of that, we've got this triangle with 16, 12, and C on it. C is across from the right angle, so C is your hypotenuse. When you work these problems out, always make sure that you write the a squared plus b squared equals c squared. I want to see that. And so we plug in 16 squared plus 12 squared equals c squared, and then you work that out. So you figure out what 16 squared is, which would be 256. And then 12 squared is 144. So sorry, that's my light's kind of in the way. So then you'd add 256 and 144 and get 400. And that's what c squared is, but you want c. So to get c, you're going to take the square root of 400. So that shouldn't be any big deal for y'all to take the square root of 400. So c is 20. And that would be your answer on that one. So let's see another one. Let me erase this. I'm going to go old school. Okay, so got one like, let's see, we've got this triangle. Let's see, this is, let's say this is T, and this is 5. This is the square root of 61. So we've got that triangle right there. We want to find T. So again, I'm going to write a squared plus b squared equals c squared, because I always want to write out the formula, because I want to see the formula. I want you to know. I want to know that you're getting it memorized, that kind of stuff, if you don't already have it memorized. You've got to be real careful where you place things. The square root of 61 is your hypotenuse. It's what's across from the right angle, right there. So when we plug in, we'll put t squared plus 5 squared equals the square root of 61 squared. So that's what that'll look like. Again, we got to put the square root of 61 in for c, because that is your hypotenuse. So that's the biggest thing on this, is making sure you get hypotenuse where it's supposed to go. Then you go from there. So we still have t squared. 5 squared is 25. The square root of 61 squared is 61, because a square root and squaring are inverse operations, so they're going to cancel each other out. So that just leaves a 61 there. So then subtract 25 from both sides, which you figure out what 61 minus 25 is 36. Then again, that's what t squared is. Sorry, my lights are blinding everything. And then t would be 6. Pythagorean theorem. Again, this should seem familiar to you. Now, one thing you do have to watch is, let's see, we've got 10, 10. This side is m, that's your hypotenuse. Sometimes you're going to be asked to write it in simplified radical form. Simplified radical form. Actually, when we got t equals 6, that's technically simplified radical form, because you took the square root of 36 and it's simplified to 6. Sometimes though, when we do simplified radical form, we're going to have a radical left. So when we look at this triangle and we want to find m in simplified radical form, we use our a squared plus b squared equals c squared. I want you to write that every time. And then we plug in 10 squared plus 10 squared equals m squared. M is your hypotenuse, because it's across from the right angle again. So this is 100 plus 100 equals m squared. So that's 200 equals m squared. Now, here we're asked for simplified radical form. So for simplified radical form, that means we need to take the square root of 200. Let me move up here because I'm running out of room. The square root of 200, and this 200 is not a perfect square. It doesn't have a perfect square root. So this is where we do the prime factorization, like I've shown you to simplify radicals. So you take 200, a couple of different ways to do it. You can divide by 2. That leaves you 100. Now there's a couple of different ways you can go from here. If you recognize 100 is a perfect square and its square root is 10, you could do this, and then you take the matches. So it turns into 10 square roots of 2. Or if you don't recognize that, if you don't recognize this, then keep dividing by 2. That'll give you 50, divide by 2 again, gives you 25, and then 5 and 5. And then again, you take the pairs. So you take 1, 5, and 1, 2, and then 2 times 5 is 10. That gives the 10 on the outside, and this 2 stays on the inside, okay? We've gone over that before. So simplifying radicals isn't new, but again, it's probably been 2 weeks at least because y'all have had double spring break since then. So let's do another one where we need to simplify that radical. Let's see. So I've got this. I'll just use m again. That's m. That's 8 and that's 12. So again, we want to find m. So a squared plus b squared equals c squared. So we're going to plug in 12 squared. Whoops, that's kind of bad looking. 12 squared plus 8 squared equals m squared. Because again, m is across from the right angle, so m is the hypotenuse. So it goes in for c. So 144 plus 64 equals m squared. And then when we add 144 and 64, we get 208. And then we want simplified radical form. So we want simplified radical form. That means we have to take the 208 and take the square root of it. And 208 doesn't have a perfect square root. It's not a perfect square. So we take 208 and we divide by 2. That's 104. Divide by 2 again is 52. Divide by 2 again is 26. Divide by 2 again is 13. Again, like, I know I went over that fast, but you can watch this over and over. You can rewind and watch it again and again if you need to. But that's the simplified, that's the prime factorization. So we take this 2 and this 2, multiply those together, so it's 4 square roots of 13. That stays underneath. So again, that's simplified radical form. Now, if you want a decimal approximation, I know this isn't the same calculator you've got, but what I'm going to show you is going to work the same on your calculator. So if you want to take the square root, if you don't already know this, I think we've talked about it before, but just reminding you again, on your calculator, you have a second key, just like this one. So you're going to hit, hold on, you're going to hit your second key, and you're going to hit x squared. And that's going to bring a radical on your calculator just like that. You'll type in 208, and then there's your square root, and round it. You know, if you want it rounded to the nearest tenth, that'd be 14.4. Nearest hundredth would be 14.42. So just read that carefully. But make sure you follow the instructions. If it wants simplified radical form, it's got to look like this, or a whole number. If you want a decimal approximation, put it on your calculator. Okay? Then also in this lesson, let's see. You can decide if something is a right triangle or not. So what'll happen, sorry, it's kind of going wild. What'll happen is you'll be given numbers like 4, 5, and 6, and you'll be asked, you know, is this a Pythagorean triple? Okay, so you got to know what a Pythagorean triple is. A Pythagorean triple is 3 whole numbers. They have to be whole. They can't be decimals, they can't be fractions, they have to be whole numbers. So before you check anything, You got to make sure it's 3 whole numbers. So 4, 5, and 6, those are 3 whole numbers, so that's good. That works, okay? So the first thing, we got to be 3 whole numbers. Then they have to satisfy, meaning make it true, satisfy a squared plus b squared equals c squared. So you've got to make sure it passes the first test, that it's 3 whole numbers. So 4, 5, and 6 pass that first test, it's 3 whole numbers. And then it's got to satisfy a squared plus b squared equals c squared. So you're going to plug it in. You're going to do 4 squared plus 5 squared equals 6 squared. You're going to write a squared plus b squared equals c squared first. And then 4 squared plus 5 squared equals 6 squared. So then 4 squared is 16, 5 squared is 25, 6 squared is 36. And you see if 16 plus 25 is 36, which it's not, it's 41. So that doesn't work, so it's not a right triangle. Not a right triangle. And so that's how you'd answer a question like that. You'd be asked if it is a Pythagorean triple, or if it makes a triangle. Usually it says Pythagorean triple. And again, it's got to be 3 whole numbers. If it's not 3 whole numbers, don't even check it. Don't even plug it in. So you got to make sure it's 3 whole numbers first. So if I give you something like 3.2, 4, and 6, this is no, because they're not whole numbers. It's not 3 whole numbers, so we don't even check it. So you just go on. You put no, circle or underline the problem. The 3.2 is the problem because it's not a whole number, and go on to something else. But you've always got to make sure they're whole numbers first, okay? Let's try 9, 12, and the square root of 225. 9, 12, and the square root of 225. So the first thing you have to do is see what the square root of 225 is. Because if it's not a whole number, then you don't go on. You don't even check it. So I can't stress to you enough, you got to make sure it's 3 whole numbers first. If it's not 3 whole numbers, then you can't do it, okay? So you just put no and go on. So on this one, we check our square root of 225, and it is 15, so that means we can check it. So we're going to check it in a squared plus b squared equals c squared. So 9 squared plus 12 squared equals 15 squared. We're going to see if that works. So then 9 squared is 81, 12 squared is 144, 15 squared is 225. We figured that out up here. And then we add 181 and 144 and make sure it's 225. And it is, so this is yes. This is a Pythag, and I just do Pythag. Sorry, I don't do that either. I just say a pi trie. That is not a mathematical term. That is a McKinney term. But it works, and it keeps you from having to write out, yes, it's a Pythagorean triple. So you can just put, yes, it's a pi trie. So let's see. Let's try another one of those to see if they're Pythagorean triples. 15, 16, and the square root of 481. 15, whoa, that's a 6. Well, that's even more 6. Okay, so the first thing we do is check that square root of 41. We got to see if that is a perfect square, if that comes out to be a whole number. It doesn't. This is about 21.93, so this is no. Not all, not 3 whole numbers. So don't even check it. Don't plug it in. Don't do anything with it. Yeah, so make sure you check that first. Make sure it's 3 whole numbers first before you plug it in. Okay, so one other thing is you're going to, of course, have a couple of word problems on this. Let's see. And it's usually about a ladder. So I'm just going to make one up. A ladder is, oh, give me a good, six feet from the bottom of a building and reaches 20 feet up the building. Okay, so a ladder is 6 feet from the bottom of a building and reaches 20 feet up the building. So a big thing you need to do on this is draw a picture. I want you to draw a picture so you can see what's going on. We assume that the building and the ground make a right angle. So this is your building, this is the ground, this is the ladder right here, this is the ladder, because it's leaning up against the building. And it reaches 20 feet up the building and 6 feet away from the building. And of course we want to know the length of the ladder. We want to find the length of the ladder. So length of ladder is what we're trying to find. Length of ladder. So again, a squared plus b squared equals c squared. And your ladder is c. Your ladder is always the hypotenuse because it's what's leaning against the building. So 20 squared plus 6 squared equals L squared, since it's ladder. So then we figure out what 20 squared is, 400. 6 squared is 36. And then that gives us 436. And so we're going to take the square root of 436. 436 is not a perfect square. So that gives me about 20.88 if I round it to the nearest hundredth, and it's in feet because these are in feet. So make sure you label. Now that's to the nearest hundredth. So if you wanted it to the nearest tenth, it'd be 20.9. Nearest whole number would be 21. So just make sure you read your instructions carefully to know what you need to round it to. Okay, so that's the way you're going to need to set up H. H tells you that the ladder is 8 feet from the base of the building and the top of the ladder touches the building 32. So on the practice one, on practice H, you're going to put the 8 here and the 32 here. And then you're going to follow all this stuff. So instead of the 20, you're going to put 32. Instead of the 6, you're going to put the 8. And you're going to round it. It says round to the nearest tenth, so you only want one decimal place. So that's how you're going to work H. Then